Hi everyone, this is the next Pencast for 11.2 full conics. Today we're going to be doing problem set 11, problem 3a from problem set 11, which says write the equation of each conic described below. And we're going to do A, which gives us eccentricity of 5 over 4 and foci at plus or minus 3, 7. So, we don't know yet whether it's going to be a hyperbola or an ellipse, but what we can get from the foci is the value of c right away. So, c, which is the distance from each foci to the center, c is the distance from each foci to the center, and so we know that the distance between the foci is going to be equal to 2c, because the distance from one foci to the center and then the center to the next foci, that's going to be a distance 2c. So we can say that 2c equals, well, we've got negative 3, 7, which is 3 away from the center, and then positive 3, 7. So that total distance is 6. So then we solve for c. c is equal to 3. So now that we have found c, we can use the eccentricity here, 5 over 4, to solve for our a value. So we say that E is equal to c over a, which is also equal to 5 over 4. Now, c we know is 3 over a equals 5 over 4. Look at that, a equals 12 over 5. Great. So, also, from the eccentricity, we can find out what type of conic we are looking for. So, 5/4 is greater than 1, and because it's greater than 1, we know that we are going to be writing the equation for a hyperbola. And that'll come in handy later when we're writing the equation. But back down here, we've got A, we've got C, and we know that the relationship of A, B, and C in a hyperbola is A squared plus B squared equals C squared. And if we just plug those numbers in, we get a value for B squared, which is what we're really going for, of 81 over 25. Now that we know A, B, and C, we can start outlining the general equation for this equation. So the general equation for a conic is ax minus h squared, x minus h squared over a squared minus y minus k squared over b squared equals 1. So, from here, we know a squared and b squared. So, we know x minus h squared, a squared is 144 over 25, and we are going to flip that because it's over a squared. So we end up with 25 over 144 minus b squared, which is also flipped, 25 y minus k squared over 81 equals 1. Now, what we need now is the values of h and k. Well, h and k can be found using the foci again. The foci in a hyperbola are always going to be along the transverse axis. So if we imagine these foci plotted on a graph, that graph, I'll start making that graph down here. This is x and y. So we've got negative 3, 7 and positive 3, 7. This is going to be the transverse axis right here. And this would be the center right in between those two, which is the midpoint between the foci. So in this case it is 0, 7, because that is the midpoint between negative 3, 7 and 3, 7. So now we go back to our equation that we're writing, and this just stays x, 144 minus 25 y minus 7 squared over 81 equals 1. And there we have our equation for this conic, which we can also check. We can check that the transverse axis is positive, which is in the x direction. So is our transverse axis positive, or in the x direction? Yes, it is. So that also lines up. So this is about what the graph should look like. But what we're really concerned with is the equation that we just wrote. So as a recap, we found c because the distance between the foci is going to be 2c, and then we used that value to find a through the eccentricity. And because the eccentricity was greater than 1, we knew that we were looking for a hyperbolic equation. Then we used the values of a and c to find the value of b. We plugged those in to our standard equation over here, and then we used the foci again to find the center, because the foci are always along the transverse axis, and the center is going to be the midpoint between the foci. That happened to be 0, 7. So we put in y minus 7 here, and we know that our equation is good because the x term is positive and the transverse axis is parallel to the x-axis. So that is all good. Okay, have a good night.